So as you can see that I need to first calculate my zi values. So the summation zi values are simply the inverse of the qi values. So those are the summation of 1 divided by q sub I values. So in that case it will be 1 divided by 260 plus 1 divided by 189 plus 1 divided by 120 plus 1 divided by 87 plus 1 divided by 75, because those are the values which are given to me. These are the individual q values. I have to take the inverse of each q value and add them up to get the summation of zi values. And this number here turns out to be 0.042298. So similarly, I'm going to calculate my other summation which I need. I need the summation of the ti values, just simply the summation of all the time values. So that gives me 2 plus 6 plus 10 plus 14 plus 18. That's all the t values which I have. That gives me 50. So similarly, I can, let's suppose I'm going to calculate my ti zi summation, which I also need. And that will be the values of the t values, which is 2. Then the inverse of the q values, which is 1 divided by 260 for the first one. The next one will be 6 times 1 divided by 189. The next one will be 10 times 1 divided by 120. So all of these values which you're seeing here, this is the t value and it's the corresponding inverse of the q values which are given for the data. So that's all I'm doing here. So this will be 14. It will be 14 times 1 divided by 87 plus 18 times 1 divided by 75. And that value turns out to be 0.52369. So we need one more summation, so let me just go through the whole thing as opposed to just telling you to do it as homework. We need summation of ti squared. That's simply taking each individual t value and squaring it. And those values turn out to be 660. So these are the summations which I need in my linear regression formula which I wrote for A0 and A1. So let me go ahead and find out what those A0 and A1 values are. So I'm going to find my A1. A1 is n. N is the number of data points which I have, which is 5 in this case. Then the summation of zi ti, which is 0.52369. Minus summation of zi, summation t sub I. Summation of z sub I is 0.042298, and the summation of t sub I is 50. And this whole thing is getting divided by n times summation ti square, which is 660, and n is 5, so I can substitute that. N is 5, and then I have 660. Minus summation t sub I square, which is 50 square. So these are all the summations which I needed, and those are the ones which I showed you in the previous board here. And this A1 value which you are getting here turns out to be 6.2944 times 10 to the power minus 4. And now you need to calculate A0, which is the z bar minus A1 t bar. Z bar is nothing but the average values of z. The z value is 0.042298 divided by 5 because I have 5 data points. A1 I just found 6.2944 times 10 to the power minus 4. And t bar is the average value of the t values, which is 50, is the total value divided by 5. And this A0 value turns out to be equal to 0.0021652. So these are the constants which are coming from the z versus t data formula, but that's not what we are looking for. We are looking for the values a and b of the harmonic decline curve, and we know that b is nothing but 1 divided by A0. B is nothing but 1 divided by A0, so it will be 1 divided by 0.0021652, and that value turns out to be 461.85. So that's what I get for the value of B. Now A is nothing but A will be A is equal to B times A1 is B times A1. That's what A is. And I know B, which I just found out, which is 461.85, and A1 I just found out to be 6.2944 times 10 to the power minus 4, and that value turns out to be 0.29071. So what I've been able to do is I've been able to use the transform data to use my linear regression formulas to calculate my A0 and A1, and then backtrack my values of A and B of the harmonic decline curve. So what that tells me is that the harmonic decline curve which I have is now Q divided by Q is equal to B 1 plus AT, and B I just found out to be 461.85 divided by 1 plus A, which is 0.29071 times T. So the two questions which were asked of me was to find out what will be the production at 60 months, and the second question was, hey, what will be at what time will the production be 20 barrels per day, so that you can figure out when to abandon the well. So if you look at part A, we want to find out what is the value of the how much barrels per day are being produced at 60 months. So I'm just going to plug in 60 into the formula which I just derived for the harmonic decline curve. And this value here is turning out to be approximately 25 barrels per day. So that's what you're getting. So at 60 months, you'll have about 25 barrels per day. The second question was that at what point is your production 20 barrels per day? So you know that it is going to be more than 60 months, because at 60 months you are still producing 25 barrels per day. So it has to go a little bit further to go to 20 barrels per day. So how we're going to do that is by saying 20 is equal to 461.85 divided by 1 plus 0.29071 T. So from here I can find out what T is by saying 1 plus 0.29071 T is equal to 461.85 divided by 20, and T will be equal to 461.85 divided by 20 minus 1 divided by 0.29071. That's simple algebra which you are trying to do there, and this time here turns out to be approximately 76 months. So what you're figuring out here is that you are getting the time that when the number of barrels which will be produced will be 20, it will be 76 months. So that's when you would abandon the well, if that was the limit. You would like it to have 20 barrels per month. And that's the end of this segment.